Welcome, guys. So let's look at this start question hypothesis test question. Let's read. A researcher is interested in finding out whether the average gasoline price is higher than $2.45 in Midwest region. The sample analysis consists of 25 observations, a sample mean of 2.65, and a sample standard deviation of 0.35. So it says state the null hypothesis and alternative hypothesis, and then also at a 99% confidence level, is there enough evidence to discard the null hypothesis? Okay, so this is the question. It's a lot, but relax. We are going to digest everything over here. So first off, we have to write the data or the information given. So over here, we have been given is higher than 2 so the 2.45 you see here is the population mean. That's the mu. The population mean is 2.45, and then they said a sample, then the sample has a number, the sample size is 25. Over here the sample size is 25, and then has a mean, then the sample mean is equal to 2.65, and then the standard deviation of the sample is 0.35. So now the next thing we have to look for, this is a test, hypothesis test. So which type of test are we going to use? Are we going to use the z-test or the t-test? Are we using the z-test or the t-test? So I always say, if you want to know which of these tests to use, you have to look at the sample size. When the sample size is less than or equal to 30, you use the t-test. And when the sample size is greater than 30, you use the z-test. So in this case, our sample size is less than 30, which means we are going to use the t-test. So the t-test is equal to the mean minus the population mean all over s over the root of n. So this is the formula we are going to use. This is the formula we are going to use to test whether we are going to reject the null hypothesis or fail to reject the null hypothesis. So now let's start with the A. We say that we should state the null hypothesis and then alternative hypothesis. And I said, for you to know how to state a null hypothesis, you have to check from the question. There have to always be a claim. Then somebody will come in to disclaim or say something about it. So in this case, the researcher will go for the alternative, and then the claim here is that whether the average gasoline is higher than. So the researcher is saying whether the gasoline is higher than. So the alternative, the null hypothesis becomes mu is equal to 2.45. The claim there already, we say the gasoline is equal to 2.45, but the researchers want to know whether it is higher. And the word higher means, when we talk of higher in mathematics, we are talking of greater. Where we talk of lower, we are talking of less than. So the alternative hypothesis becomes mu is higher than 2.5. So we are going to test whether it is higher or is equal to 2.5. So from here we go and look for the critical region. That will help us to know whether to reject this null hypothesis or to fail to reject that null hypothesis. Now we are going to look for our critical. So this is the first one we see. So we should state this is the null hypothesis and the alternative. Now we are looking for whether the second one says is there enough evidence. So now let's go and look for our critical region. So over here we draw our, and take note, this is a one-tailed test. Because the alternative hypothesis is only talking about higher, only one side. So it was supposed, if it was let's say the difference, if the question was talking about a researcher was talking about whether to know the difference, that one is two-tailed, but this was talking about one side, higher. So only the higher side. This is a one-tailed test, and I'll specially made a video on that. whether to know whether it's 1 tail or 2. So this is a 1 tail test, and this tilted higher because it will be going to higher means to the right side. So this is a 1 tail test to the right side. So we'll look for the critical region. So over here we have a 99 confidence, which is 0.99. So the left 0.99, what is left is 0.01, and that is the rejection region. So we have to go and look for that critical value. And for you to get the critical value, in this case we use the T table. Unlike the other side, when the number is greater than 30, we use the Z table. Here we use the T table. Yes, for you to know the T table, you need your degree of freedom. And for finding the degree of freedom, is simply n minus 1, where n is the sample size. So our sample size here is 25 minus 1. So our degree of freedom is 24. So on the T table, you look for an alpha of 0.0 on the horizontal side, and then a degree of freedom of 24 on the vertical side. Yes, so from the table, and I'll do a video on how to use the table, but for now I will only give you the answer from the table. The answer is 2.49. So this is the critical value, 2.49. So this is the critical value. Any value which falls within this will be rejected. So now let's go and solve for our test. Let's go and test whether we are going to reject the null hypothesis or not. So now we are using this formula. So now T is equal to X bar, which was giving us 2.65, minus the population mean, which was 2.45, all on the standard deviation 0.35, all over root of 25. And let's try to compute everything, and by computation we are getting 2.86. Let's compare 2.86. Where will it fall? 2.86 will fall somewhere here. 2.86 will fall somewhere here, and it is in the critical region. So in conclusion, we will say reject the null hypothesis. Reject the null hypothesis. We are going to reject it, which means that what the researcher was claiming is true, that the average size is higher than 2.5. So we are going to reject the null hypothesis. Thank you for watching my video. See you in my next video.